Alright guys, Mrs. Butcher here. This is video 6.2-10, solving harder logarithmic equations and inequalities. So remember to solve an exponential equation when our variable is in the exponent, but you can't make the bases the same. We're going to rewrite it as a logarithm, and then you can use your calculator to solve it. So let's start with an example, a harder example. Alright, we have 5 to the 2x power plus 8 equals 7. So remember, before you can rewrite it as a logarithm, we have to get this 8 out of the way. So we're going to say 5 to the 2x power equals, and then 7 minus 8 is -1. So now we can't get 5 and -1 to have like bases. So we're going to write this as a logarithm. Log base 5 of -1 equals 2x. Only you can't take log base 5 of -1. That's not possible, so there is no solution to this problem. Alright, our next example, -6 to the 3x power plus 6 equals 5. And that negative is not in parentheses, so the negative is not being raised to the 3x power. So first thing we need to do is subtract the 6. -6 to the 3x power equals 5 minus 6 is -1. And then we're going to divide off this negative sign, basically divide both sides by -1, and have 6 to the 3x equals 1. Then we can change it to a logarithm. Log base 6 of 1 equals 3x. And log base 6 of 1 is 0, so 0 equals 3x. And x equals 0. And if you plug that back in, it works just fine, and we're done. Okay, the next example we're going to do, this is complicated. It's -3, and then times 2 raised to the 5x minus 2. Then plus 15, then equals 9. So remember, we have to isolate our exponential part first. That means the first thing we need to do is take away 15. So we have -3 times 2 to the 5x minus 2. And then 9 minus 15 is -6. Then we need to divide off this -3 so that we have 2 to the 5x minus 2 power equals 2. And now that our exponential part is isolated, we can change it to a logarithm. Log base 2 of 2 equals 5x minus 2. And log base 2 of 2 is 1, so 1 equals 5x minus 2. And now we're just doing our baby algebra and solving for x. 3 equals 5x, 3/5 equals x. Alright, we also did equations that were logarithmic, and we're taking the log of our variable, so in order to figure out what that variable is, we have to rewrite it as an exponential. So here we've got the base of 3 raised to the -2 power equals x. And 3 to the -2 power is 1/9, so 1/9 equals x. We could also do one like this. 12 equals 5 log base 2 of 3x. So we're going to have to rewrite this, and we're going to need to isolate the logarithm. So the first thing we need to do is divide both sides by 5, and we have 12/5 equals log base 2 of 3x. And then this isn't written in the form we usually have we usually see it with the logarithm written first. So if it helps you to remember which way to rearrange things, just put your 12/5 on the other side so that you can take your 2, raise it to the 12/5 power, equals 3x. So we'll take 2 to the 12/5 power, just do that in your calculator, and then divide it by 3, and you'll get x equals 1.759. Alright, one more of these. 1/3 ln 3x equals 5. Remember, we need to isolate our logarithm, so we need to multiply both sides by 3. So we have the natural log of 3x equals 15. And then you have to remember that the base on the natural log is the letter e, so we're going to take e to the 15th power equals 3x. And then we have to divide both sides by 3. So you can punch e to the 15th in your calculator and then divide it by 3. And it's a very big number. We have 1,089,672.457. And that's okay, because e to the 15th is really, really big. Alright, now here's something new. What happens if you're given a logarithmic equation that has multiple logarithms in it? As a bunch of them, all added together, subtracted, whatever. In that case, you have to condense first. We need to condense these two down. And we did that several days ago. Okay, if I could spell condense, it would help. C-O-N-D-E-N-S-E. We're going to condense that down. It's addition, so we're going to say log base 6. And then addition turns into multiplication, so x times x plus 1 equals 1. Then we can do our rewrite. 6 to the 1 power equals x times x plus 1. And if we distribute that out, that's x squared plus x. So this is going to be a quadratic, and hopefully you guys remember that anytime you need to solve a quadratic, you need to set it equal to 0. So I'm going to say 0 equals x squared plus x, and then I'm going to subtract the 6. And we have multiple ways of solving quadratics. You can factor it, you can use the quadratic formula, you could do completing the square if you wanted to. There's lots of ways you can do it, and I'm not going to tell you what specific way you have to use. This particular equation factors nice and pretty. X squared plus x minus 6 is x plus 3, and x minus 2, because 3 times negative 2 is negative 6, and 3 minus 2 is 1. And so that means that x has to equal negative 3 and positive 2. But then make sure you check it. If we were to plug in a negative 3, we would be taking log base 6 of negative 3 plus. Now I'm not even going to go any further because I can't take the log of a negative number. I know that negative 3 can't work. And then if I plug in a 2, I'm going to be taking log base 6 of 2 plus log base 6 of 2 plus 1 is 3. Both of those are fine. And then that should equal 1. So 2 works. Our final answer is only x equals 2, because the negative 3 was extraneous. Okay, here's another one of those. We have the natural log of x plus 2 plus the natural log of x equals 2. So we need to condense this down into the natural log of, and then once again it's addition, so it turns into multiplication. X plus 2 times x equals 2. So this one's very similar to the one we just did. Now the base on the natural log is e, so we've got e to the second power equals, and then I can go ahead and distribute that x and get x squared plus 2x. It's a quadratic, so set it equal to 0. X squared plus 2x minus e squared. And you don't want to punch that in your calculator just yet and round it off, because when you round off in the middle of a problem, it messes up your final answer. So just leave it e squared for now. But you know that you can't factor with an e squared, so what we're going to need to do is use our quadratic formula. X equals negative b, so negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a is 1 times c is negative e squared, all over 2a, and a is 1, so 2 times 1 is just 2. You can punch that in your calculator, and just when you get here, use the actual e button, and then you'll get 2 answers because you have 1 plus and 1 minus, and I get 1.896 and negative 3.896. And then if you look, we know we're not going to be able to use the negative answer because we can't take the natural log of a negative number. So the only solution that works is x equals 1.896. Okay, the last ones we're going to do are our inequalities. So remember, when you're doing exponential or logarithmic inequalities, just use your graphing calculator. We'll graph 15 times 8 to the x power is greater than or equal to 7. And then make sure you draw the graph. So we'll sketch it out here. I'm just going to do it by hand because it doesn't have to be perfect. But I'll put 15 times 8 to the x. That's going to be this graph right here. And then 7 would be this one right here. And then we're looking for greater than, so where is the curve above the line? and that would be all of these values and then going on forever, so that corresponds to an x value starting over here somewhere, going on forever that way. So then you can do second calc intersect to get that answer, and that answer is negative 0.367. So it's all the x's that are greater than or equal to negative 0.367. Greater than or equal to because that's what we had in the original problem. Our next inequality is 5 log base 3 of x plus 2 is less than negative 2. So let's start by sketching the graph. 5 log base 3 of x plus 2, it has a vertical asymptote at x equals negative 2. Remember that? And then it's going to go like this, up like that. And then y equals negative 2 is down here. So we want all the x values that correspond to where the curve is less than, so below, the line. So all of these, which isn't very many, because we have a starting point here at negative 2, and we have an end point here. We're going to have to do second calc intersect, and when you do that you get negative 1.356. So it's a very small interval here, but we're going to write our answer. Negative 2 is less than x, because it doesn't touch the asymptote, is less than negative 1.356, because that's the intersection. And that's it for the harder inequalities and equations.